All right, here we are. Welcome back. I'm Agent Ultra, and I'm here to hack on some projects that we've been working on in Haskell. It's mostly what I do on the stream. Not always, but mostly. This week, and for the past little while, I've been working on implementing a database client for a database called TigerBeetle. TigerBeetle DB, or TigerBeetle, is a financial transactions database. It specializes in basically being a really fast, lightweight double entry ledger for credits and debits and things like that. Distributed, apparently got really good fault tolerance, kind of fast, surprisingly small to run in terms of a binary size and things like that. So pretty cool little project. I've been learning quite a bit about it, trying to implement a client for it and how it works and all that sort of stuff. So yeah, let's get into it. Last week, I spent quite a bit of time debugging, figuring things out. Kind of made the final realization that, oh yeah, when all of your requests are async, you have to wait for them to return. TigerBeetle doesn't like it when your program makes a bunch of calls and then terminates. So we're gonna fix that this week. And what are we gonna do about it? Well, I have some thoughts. Dangerous, I know. Basically, there's two ways we can go about this. We can have like a synchronous client, right, which is the test app that we wrote last week to figure this all out. Or, and maybe in addition to, we can have an async client. All right, so this code here roughly implements a very cruddy, not very good, but the gist of a synchronous client, right? Where we need to essentially, when we make our requests, loop until we get all our results in. In this case, this is using like a T-bar, a result bar with like a maybe value in it, a maybe packet or whatever. And that could potentially work. This would be like you probably would maybe use this when you're testing things out, trying out the client, that kind of thing. Oh, let's create a count. Let's do this or do that. Because the async client is going to require you to write a little bit more code in order to get things to actually start working for you. I'm thinking with an async code, we'll have a callback and you'll basically get an STM variable, right? And then that STM bar will have your data in it for you, but you'll have to, or you'll give a callback with an STM comp. Anyways, you'll see. It's better if I explain that in code. So I think maybe we can get the sync client going with this as kind of our base idea. Just make it a little bit nicer looking. So what I'm going to do is I'm going to start with TigerBeetle client and maybe we start a module here. What do I want to write? I want to be able to write this as like we comment all this out. We're gonna get. Do we need some kind of result value maybe? Of like, say sync dot create account Oh, this probably be like sync.with with client. With my configuration, so like I need my cluster ID, I need my address. It would be kind of weird if this was a do block though, because then if we go like another action, I don't know, what's something else you could, maybe we just do create accounts again. Wow. Right, what's the value we would get in result? Right. And then if we start mixing up operations, I don't know, a debit account or something. Or even if we went like and did a query. Right, some of that kind of query in there, then what's the result, right? Right, this might be the result of the last thing you do, right? In which case you would go here, here, right, and then it would be just the final thing. Right, we're explicitly ignoring the result of create accounts since here and here on 19 and 20, but on 21 we look up the accounts and would be return that basically. Something like that. Let's go over to sync. Oh, I haven't created it yet. So create the sync client. Okay. So we're going to need the with client function. It's going to take a cluster ID, an address, and some kind of thingy. It might be something like a reader T. Or it might be a sync client T action. If we put an A here, and then we make it run in IOA, or make that M and generalize over the monad there and make it M, and then we just make this monad IO. What is this saying now? Right, well, we're gonna have to import those things first, but this is basically saying, like, you give me this sync client T and I'll run it, and I'll unwrap it and give you the result. in M. And M is going to be some kind of monad that provides I/O. I'm gonna get my builder running. GHCID. This might not quite work, because this A, right, is going to fix the sync client T actions that we can actually run in with client here, to all returning the same type. Right, so if we had imagine some action like create accounts that we wrote in our example, right, that's going to take a list of create account and return a sync client T action. Right, but the A part here, like if we make it unit, that means it's not going to return anything. Let's look at the library and what it returns there when we do create a client. Well, we submit a packet. This is what we do. And we get a client status back. Just to say if it was client OK on success, or invalid if the client handle was not initialized or servers are being closed. That's all the return does for that. The async callback gets a TB packet. Gets a struct of this. With some user data, some data, data size, tag, operation, status, opaque, and blah, 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 blah. So our kind of ideal looking API that we're going for here, I imagine sync.lookup accounts here is going to actually return like the response data itself. So we're going to parse out of this packet like the operation and the data from it. All right, so it's going to be an operation create accounts. So the response packet's going to have some data in there for us to parse. Okay, logging callback, cool. But like, what is actually in that data though is still. I don't really know what we're gonna do with that. query filter, account balance, account filter, transfers result, create accounts result T is probably it. And I'm imagining that looks like we get just an int32, an unsigned integer 32 of index and result. So I guess the index is probably, because it does batching in the packet requests. So that's like the index in that array, I guess. So you can match up the packets. And the result is probably parsable into this enum. All right, so if we were able to parse in this enum, then result here in our example program would be probably one of these values here, which I think we might have defined already. Count flags. Storable instances for the account packet. Create account result, yeah. So we'd get one of these back. We could create a higher level wrap report in the raw layer, but that's basically it. Although we don't really need to, I mean, we could just re-export it from the lower level, or just wrap it. I don't know. People might not appreciate like the TB convention that we use there for the C level things. That would be it. So to go here, it would be potentially TB create account result like this. All right, and so like if we're doing the query, let's say we're doing a query of the counts. Right, are we getting the count balance? It'll probably look like this. Maybe some kind of account, list of account IDs to get them, and then I guess we'd have to map it back to a list since we couldn't create multiple accounts on that one. Balance says. Something like that. Or is it gonna this is this balances? This is the count struct. Maybe, well, I don't know about getting the balances specifically, but it looks like we can do this with an account filter, say. Okay, so hypothetically, we can do something like that. Let's go to main. So we go create accounts, create accounts. This would be like get accounts. Some filter thing. And maybe there's an empty instance for the filter, whatever, but result here would then be the value of this. So let's see if this is even type checkable. Okay. GHC ID wants me to clean up some things first. That's fine by me. Let's do that. New TQ. AO redundant. Okay, tvar. New tvar IO is redundant, apparently. Finally is redundant. And text. Okay, I probably have to update my Cabal file here to the GHC ID to notice our new module. Go. Yeah. So monad.io comes from I forget. Controlled.monad.io class. Yeah, something a little funky. Okay, so we don't have a sync client T yet. That's basically going to be a reader T, probably. Think state. That needs to be curly braced. And then we need to derive a few things. Applicative, functor, make this a new type. Monad reader of sync state. And probably monad IO as well. And from that we go control.monad.reader. Okay, now we need a sync state. All right, so in our sync state, we're going to want the... This is like what we want to pass through to all of our subfunctions. So like get accounts, create accounts, and so on. Kind of common state between all of them. Probably going to need the client ref, client pointer, in order to make the raw calls that we need to make at the lower level. And we'll probably need... I don't know if we'll need to maintain in the sync client here the results of all the calls. Maybe just needs the sync client ref. Let's roll with it and see what happens. And see if we can't get our program to like compile and work. Okay, so it needs client ref. That's going to come from our raw layer. Unless I named it something else. Client handle? No, that's not what I want. Client pointer. I did call it client pointer. Okay. Pointer. Okay, a couple other things. Create account, what is that? We need to define that. That is kind of defined in client account. So I think we might want to refactor this out or make it a little bit different. Really, this should just create the packet. But what it is, like, taking all our create count parameters, creating the TB accounts for those, packing all of that data inside that TB packet struct, and then returning that struct for us to send off in the client submit call. Although that could probably be moved into the raw layer if it doesn't really exist down there, which it might. We have 0 TB. Okay, we have created accounts packet. List of TB account. And that gets a TB pack, a pointer to a TB packet. Okay, that's pretty useful. So in order to do a create account, what do we need here? Okay, that's an interesting warning that we need to take care of as well. The struct of our TB packet returned must be pinned. Stop jumping over there. This is interesting. Retrieve the callback context initially passed the TB client to init. I don't know what you would want that for, but okay. I mean, I think that's the add here. Maybe it's because you can, like, call init several times to init several clients. Okay, so if we want to create an account, I think we gotta fill in a TB account T struct. And we pack those into the data, into an array in the TB packet. So most of these need to be 0 when we're creating an account, I believe, if I'm not mistaken. We just have to have an ID. I mean, ultimately we could implement any of them. So, let's see. This code here, yeah, you give just the account ID and the ledger. UN32 ledger. So I'm assuming that's like a ledger ID. And map create TB account over those create account parameters. Basically creates a 0 TB account, sets just those fields, and then returns a raw TB account. Okay, I think we would lift some of this code for this. So ultimately, I should, or I could remove this part. I think that might be better. It's going to be a TB packet. That'll be from database TigerBeetle raw client. Oh, FFI only. Okay, that's fine. Through that, go to that. Now, that's an alright type, except packet T. So we don't want just a raw, like, pointer. We probably want a foreign pointer here as well. I'm guessing because TB client will probably write to some of the fields in this struct. Maybe because it reuses it for the response. Or keeping track of its internal state on the response and stuff. And where to send the response packet to. So it wouldn't want that struct being like garbage collected out from underneath it. So probably want is foreign pointer. And we get that from importing foreign.foreign pointer. Okay, so we still have something to do here. Something with TB packet pointer. There's new foreign pointer. The finalizers on this can't do arbitrary IO, as I recall. I think that's what we learned about that a few streams ago. So I don't know if we need to attach a finalizer to it. It's like, I don't know what you're supposed to do with them. Is it basically, you'll get an error message when that finalizer is called that'll point you to using a different library. Which is, oh gosh, what is it? It's either foreign pointer.safe. What's the default now? I don't know. It tells you to use something else. But we just need to make sure that we don't garbage collect it until it's done with. And so we also need it to be in like pinned in memory, so it has the same address. So let's use that. Don't need the DOS signer. Need lift.io on it though. Okay. So create accounts. Create a TP. This, now that this is returning an FFI.tp packet, I feel like it should be in the raw layer. We can do that move later though. All right, so to solve this now, we need to import that. But TB create account result also comes from the lower level in our library here. We should create a type for that, but I'm just going to fill in a nothing thing. Okay, so all this is saying now is that like this structure we've created type checks. We haven't implemented anything yet. So it's just a hint that we're kind of maybe on the right path here. If we can fill these in these undefines with an actual implementation, then we should have program in main that we wrote kind of we should be able to run it, see what happens. Okay, so let's start with client here. And we have client action. Okay. We put a hole there. All right, we got to return an MA. I feel like this might be doing a little too much in the API, but anyways, let's roll with it and see what happens. All right, so essentially, once we're here, all we can do, what we need to first do is create the state for our sync client T, so our sync state. In order to do that, we need a client. It's more like the client init result. All right, that's going to come from our raw layer. completion context, I believe, and it also needs the callback. So we need to create make completion callback, I believe. Packet. And we got to do something. Packet pointer. And put a hole there too. I don't know what we should do yet, but following the kind of guideline we have here, we need like a result var to hold our result in. I'll create a new tvar IO of nothing. Alright, so we need tvar, import control, .concurrent, stm.tvar. That comes from raw. Put that there. Right, that needs, we're in monad IO, so we gotta lift IO all of our IO actions. Okay. So we have a IO block here on line 24 that we gotta fill in. An IO unit. The first thing we're gonna do is get the packet by peeking at the pointer. And just like in our example, we'll just write to that tvar just something. If we write just packet, then basically our result is going to be packet. Which comes from FFI. And peak needs foreign. Storable. And for atomically, we need just STM, the base. Okay. And then we just have this hole here. We're expecting the packet. So we're essentially going to loop over the result variable until it's not empty. Oh no. I'm gonna run the action first. Oh, what is it? We're creating the state. Right, so if we match on init result, and there was an error, we could just show the error for now. Otherwise, we have the client pointer. Okay, that's better. And now what we need to do is create that state. Sync state. I think I might have still called it ref. Okay, now we have that. We're going to execute our client action by unwrapping it, running the reader T with the sync state. And then we just check for our result. No, I think we might not be able to quite do it that way. I think sync state might actually need our result pointer. To put its result in. Call it result bar. We'll put the TB packet in it. Yeah, and then you'll go here, run the action, and return the result of the action. That means that create accounts is going to have to do its own looping and awaiting the result. Although we said it's going to create TB account result. It's probably not, because we can't really be polymorphic over the sync state, I don't think, in reader T. Yeah, I don't think we could be able to do that. So yeah, I think our idea, it might just be that our idea of being able to mix and match different count functions here isn't going to quite pan out. Right, because if we do that, yeah. Yeah, I think we'll keep going with this just a little further. But I think what we actually probably want is to have like a high-level client ref object here. Or maybe we call create something like create client. And then we have, then we can do stuff like we would just be not indented here. Right. So on and so forth. Right. That might be where we go, but then we'd have to pass in our client ref to all of these. Something potentially like that. Let's go a little further with this one, see what turns out. Hey, Twitch D. My client does use the C library, so it is doing CFFI. We're not re-implementing the protocol. The reason for that is the TigerBeetle folks, I don't know if you know this, but for those watching who don't, the TigerBeetle folks recommend it, basically. I don't recommend re-implementing the protocol, because the way the clients kind of work is that they all actually speak the ViewStamp replication protocol to each other. And so you would have to re-implement that protocol. And if they change anything about their implementation of it, you would have to change yours as well in order to be able to keep communicating with other TigerBeetle clients. The bonus to that, of course, is that it would be in pure Haskell. We wouldn't have to call it a C library and deal with all of that. But the disadvantage of it is that, like, the protocol is not trivial. So a lot of the state management for ViewStamp replication is handled by the C client library, essentially, is what I understand. And so this is the blog post that's all about that. I'll just post that in chat. I think this might be a little bit out of date with the current API, but the idea is the same. All right, so our completion callback that we make in Haskell is going to be called by the C library to return us our client, a pointer to the packet, some data, size of that data, so on and so forth. So it is what it is. Yeah. And, like, honestly, the CFFI in Haskell is pretty darn good. I gotta say. Of all the CFFIs I've used, pretty good. Not quite like Ziggs or similar languages, because those can map really, their semantics map really closely to C, and their calling conventions are easy to match. But Haskell's is pretty good. Yeah. It kind of, I think that I've heard, I don't know this for a fact, but I've heard that the reason for that is because, like, in order to get anything useful done at the beginning when Haskell was, like, first being created, it had to talk to foreign libraries for basically everything. So it kind of grew up with an FFI in tow. Right, so we've got our sync state. Now we can run the reader. Right, so something get client sync. Or maybe I called it sync client. Right, we get a reader T here. We can run that reader T to unwrap that reader T to get down to the base monad, basically. But we got to flip the arguments around on this. I don't know why they designed it this way, but that's how it is. And we pass in our sync state here. Okay, compiles. All right, so now we can implement create accounts and try going for that. All right, so in order to implement create accounts, we take our list of create account parameters. And we do something in sync client T with it. Okay, we pull out our variables. Well, we don't have record wildcards. What's my plan for the Haskell TigerBeetle API? Is it for work or a specific project? It's kind of an experiment. Yeah, I do work at a company called Mercury, and I work on like payments, card payment transaction processing there. And this is just kind of like a little experiment, just learning about TigerBeetle in general. Could it be useful for us, maybe, potentially? And also just to learn about it in general. I find databases interesting and fun to think about and to work with. And I think there's a lot of cool, space to explore in the database world. I mean, the adage is everything could be in Postgres, but maybe not everything. I don't know. But yeah, it's more curiosity, I guess. So it is an open source library. I do, I accept new contributors, right? We have one at least, maybe two contributors. And so it's a community library, so hopefully it will keep on. And if somebody else wants to take over as the lead maintainer, they can totally do that at some point. I don't know, but we'll see. So we get the sync state. We get the variables out of it. And now we can implement this kind of like loop here to read out, to basically submit our packet and await the results is the part we have to do here. The thing, I think, I'm not going to, yeah. I anticipate that being kind of a pain in the butt. There's going to be a repeatable pattern. Maybe there's a way you can abstract that out or extract it out. So the repeated parts can be handled like in with client, and then create accounts can just handle like submitting the packet. But we'll do it a couple of times and we'll see how it feels and how it looks code-wise, and if we can manage to do that. Let's just get it working first. So we have sync state, we have in scope now our raw client pointer and our tvar for the result. We're just going to get the packet back and just put that in the tvar. We could return this value here. Oh, actually, that makes me... Now I'm interested why that compiles. Oh, of course it compiles, because we said it's going to be return a TV packet. We don't know that we want to pass... This code doesn't know that we're trying to pass create accounts to it. So create accounts is going to be like... That can't be a TV packet. I have to change it like that in order for it to actually compile in our example. Anyhoozle. Right, so we wrote the code for not that account, not that level, create accounts. Yeah, we modified this to create a pointer to our request packet. So we can go ahead and create that. Yeah. I'll call it request packet. Lift IO. Lift IO. Create counts. Ooh, it's going to be a name clash, isn't it? Qualified as account to fix the name clash. Although maybe just renaming it would have been easier. I don't know, whatever. Request packet, okay. Okay. So now that we have the packet pointer, we can submit that. Almost similar, almost very similar to this. So TB client submit probably takes a raw pointer, but we're going to be using with foreign pointer to unwrap it to the raw pointer. So we're going to need a couple of those, one for the client and one for the account, the packet. I guess we'll get the status. Sync state client pointer. That gets us raw client. And we get with foreign pointer request packet. I'll just call it PTR there. Package 2. Okay. And make sure that's in scope. A foreign pointer. I'm gonna lift IO this too. Okay. So then we TB client submit. Raw client, raw packet. Okay, that's that. The status is going to be client OK or something else. We have client OK, then we know that the packet was submitted and we can await a response. So this is going to be like the loop part. We're going to have to loop with... What are we going to do? Maybe we just call it await result. Await result. Looks like this. It is just a sync client. TM returning a TB packet. And we get the client sync state. Ask for them, and what do? We check if we read the TVAR result. If it's nothing, we loop, otherwise we return. Yeah, makes sense. And in fact, we probably want to move that thread delay down in the nothing branch, but there we go. Okay, so I have to lift IO that. Sync state result bar. And in case on the results, if we have nothing, we'll delay some amount. You might want to make that configurable. And then await the result again. Otherwise, we have the packet. I'm not going to DNet the client here, but we will return it. Yeah. Okay, compiles. I'm not sure that's actually going to work, but it might be just enough for us to try this out. So let's comment that out. Don't actually have that yet. Like that. And we'll just print the result. Okay. Let's actually build that. Oh, sorry. We could probably just run that. Ah, well. We don't have that on for the executable. Probably should. So let's run. Cool. Totally didn't work. Okay, we're gonna have to clean that up a little bit before we're done. Client that account. Okay, there we go. Cool. Connection refused. Awesome. We gotta run the database, of course. Let me split this out. TV run, right? Yeah. And then we can tail server logs. Follow those, yeah. There we go. Okay, and then we can run TigerBeetle. Now, the moment of truth. Will it actually work? Okay. It did. It didn't actually create the accounts. We got an error back. Okay, that's interesting. But it connected and it sent our packet. So there we go. Prague. So invalid data size probably means that we didn't pack it properly. Okay, so far, pretty okay. I'm going to keep our other example code in there. I'm going to delete the rest here. Okay. And I just want to clean this up enough to create a nice little commit for us to start from and then tackle the data packing here for this query. Okay, so we've got an untracked file, changes here. Okay, they're not all good yet, so I'm gonna stage them as a work in progress here. Ah! Curse you. This VM of mine. I should just fix it. I gotta make sure that directory exists. And has the right permissions. Blah. Yeah, to this day, I don't even know what caused that, to be honest. I just started doing that one day. I booted up the VM. Actually, it was probably a Windows WSL update that did it, but whatever. There we go. Work in progress. Sync. Add sync client. Okay. All right, so what I don't like about this from the main side of things is the fact that I think I've got to import those things. Right, in this module, we should see us importing just from the nice clean Haskell API that we want users to use so that they don't have to know about raw stuff. If I get rid of those, can I build? Do I not have all the warnings on for my executable build? Okay, I guess I don't. I don't need those, that's good. I don't want to deal with FFI stuff either. I definitely don't want to be importing from there. Okay, so I don't have to. Can I just turn that on in Cabal? common default, import defaults. Okay, WL GHC options. I do that. Okay, cool. I shouldn't, well, maybe it's not actually working because I shouldn't need those either. Ah, there we go. Good. Good, okay. That should be all that we need, yeah. Maybe we don't even need count, because it counts only for this here. Maybe that's fine. I'm gonna stage that one first. That one. Okay, and then in the library, I also kind of wanted to see if there's anything in there that we could refactor, kind of keep the code clean as we go, sort of thing. So we created the sync state. That's only used really internally. Wait, we're gonna fix the TB packet thing maybe. There's a way to do that. Yeah, but for now, we're just going to use it because we're just going to print it out and debug it until we figure out how to get everything working and how it all works as well. Okay, we don't have this yet, so let's just remove that. What did I do? I'm not sitting straight. Okay. That would be like a default template for my commit messages, because I tend to be very consistent with my... try to be at least consistent with my messaging and how I structure things. Anyways, so we modified this file, remove unused code. Account. Okay. The account module. I'm not super stoked about having to import that this way. And then having create account like this. I feel like it could be pulled into this module. There's no reason to load us up, except there could be. There could be, actually. The difference between this create accounts and what will be used in the async client is not... This might be common between the two. Right, packing the packets is still going to be the same. It's just the only thing that's going to be different, it's going to change between them, is how the data is delivered to the user of the library. Right, in the sync case, we're going to await the result and return some result data to you synchronously. So we're going to block basically when you make a call and do that. Whereas the async client, you're going to give us a call back and we're just going to deliver this to you at some point, and you're going to handle all of that, the asynchrony of everything. And the parallelness and everything else. So that might be fine. Okay. Let's squash this all down. Reword that. Okay, so this adds a database.tigerbeetle.client.sync and changes /main. It doesn't really remove anything. The gist of it is sync module synchronously awaits results from TigerBeetle. Or more precisely, the TB client. Okay. So, onward and upward. We need to get more time. Running low on time. We're going to stop in about 15 minutes or so. Okay, so we have create accounts. It's submitting the packet fine, but we're not packing the data properly when we do that. Because it's turning it invalid. Whatever. So let's look at how we pack the data. So we need to look at our account FFI layer. Right, and figure out how we do that. So I think I'm not mistaken. We could create a 0 TB account for the raw layer. All right, which is... I don't know why that's in IO, actually. But it just creates a TB account struct. S.empty. Depends what S. It's just data.set. It's just an empty set. This is the meat and potatoes, it looks like, though. Create accounts packet. That's what we call in our code. To create the TB packet that we send into our request submission. So we pack accounts. A list of TB accounts. We pack each of those. Account data. Where pack? Okay, here's pack. So we allocate a TB account. Then, for each in the pair of accounts, so each index an account in our list. It's not really offset, it's more like index. A poke element offset into that array, or into that pointer at X. Account. Now I think poke elem off does do the size of calculations for us to do that. Just going to double check that. Poke element offset takes a pointer to some a, an int, a value of a, and then writes that value to a memory area regarded as an array of values of the same kind. So poke element offset is basically the same as poke at address, adding pointer, the index, and the size of x. So as long as the size of in our storeable instance for our TB count is correct, that's how we calculate the offset if we were to create an array of that by pointer with x. So index is fine. Right, an int value here is as an index is fine. Starting from 0. Malloc. I think it's for not pointer. All right, just creates a pointer A. Right, so this malloc call is only going to allocate for one TB account. That's probably our first problem. So probably not quite. So we might actually more want malloc bytes, but we're gonna have to calculate the size of the block we want. What we got a pack here? That's gonna be length of accounts times the size of a TB account. Okay, I'm gonna get GHCD running again on here. Size of wants a value. Yeah, it's gonna want to know. That comes from foreign, not storable. Value of the argument is not used. Why can't I just type apply it then? And use reflection. Okay. So we technically need this to be a non-empty list in order for this to work safely. Yeah, something like that. So let's pattern match on. Don't need those, but we still need accounts. And then we have to pack for the empty list. We don't need to do really anything other than return an empty pointer like we were before. Except it'll be allocated for a single thing. That's kind of rare. We could just throw an error here. It's also not nice. But it is an IO, so it's fair. Ooh, oh, did I mistype something? It looks like I did. Sorry. Okay, so that compiles. Does it work? Let's see. Still got invalid data size. Okay. So the next part we look at here after we pack accounts is we malloc a packet pointer and we poke that pointer with a TV packet. We give a null pointer for user data. Maybe data size here. It's not quite right. We don't want size of account data, perhaps. Length of accounts. Maybe they want it in terms of like index and not bytes. Still got invalid data size. Okay. Well, we have something to work on for next week. Because now we have run out of time. Our 15 minutes is up. Our evening together is coming to an end. It's been wonderful. Thank you for hanging out with me on the stream and following along. Have a great night, Twitch TD, and everybody else who's watching. I do these streams on Wednesday evenings now at 10 after 8 in the Eastern time zone. So wherever that is, where you are, it's not too far off. You can come hang out. But if you follow us here on Twitch, just set up your notifications and all that, you will get notified when I go online. If you're watching this from my VODs, which I back up on my YouTube channel, then give us a like, a subscribe, leave a comment, and that helps boost the channel and finds new viewers who might be interested in following on, like Haskell and that sort of stuff. You can find my website at agentaltra.com, or you can follow me on socials here on the types.pl server at Agent Ultra, where there's links to my YouTube channel and all that stuff, as well as this channel here. And if you go to the link above my head, that's declarative.tv. Declarative.tv is a cool little website run by some colleagues and friends who also do streaming in languages like Haskell, but other declarative languages as well. So you might find someone else there to follow who's also doing cool stuff they might be into. There's also a link to a Discord server on that website where we have a channel for this stream. So if you didn't get a chance to ask a question on stream, or you want to show off your project, just chat with other like-minded folks, find us there and hang out. It's great. What else? I think that's it. So hopefully I'll see you next week. May your monads be free, and may your types always check. Happy hacking out there.